Hey there, Dangar Stu here. Today's video is about converting an outboard to freshwater cooling and is proudly sponsored by marineengine.com. This is a project I've been looking forward to doing for quite a while. I'm filming this from the point of view of figuring out whether it's even possible. I mean, everything's possible if you try hard enough, so I know there'll be a way, but I have no idea how that way is yet. So we're going to start here right from a bit of a feasibility study. I'm going to use the dead power head that we swapped with the other outboard here for a bit of experimentation. Then we're actually moving on to a larger 4-stroke motor to do the actual conversion. The best place to start really is probably to explain what I mean by freshwater cooling and what an outboard does normally. So normally an outboard will pick the water up from under the boat, whether you're in a lake, a river, an ocean, whatever, and take what they call raw water, just unconditioned water, whatever you're floating in, and pump it through the engine and straight out again. There's no reason to cool that water because it's already, around the 20 degrees or less temperature, 25 if you're in a beautiful spot. So you pump it through the engine and you spit it out. When you have an engine cooled by coolant, which could be just water, could be glycol, whatever, it's a closed system. So you circulate the same coolant over and over again. And that's what your car does. It's what an inboard diesel does, like on Renko. And that coolant therefore needs cooling. Because it's being pumped around and around, it'll just get hotter and hotter and hotter. In a car, it's cooled by exchanging that heat through a radiator, which is through air. In a boat, it's through a heat exchanger, which cools the water using seawater. That probably sounds a little bit confusing, so what I'm going to do very quickly is draw some diagrams of what an outboard does normally, what a car does, what inboard diesel like Renko does, and then what we're planning to do with this outboard once we've modified it. Okay, what an outboard does is, excuse my terrible drawing, but we have our outboard, and all it does is it draws water from the ocean, it runs it through the water jackets. We'll explain about thermostats and things in a second, and spits it back out the prop. Tiny bit comes out the telltale to let you know it's pumping, but really simple. Downside to this is that salty water, I live in a salty river, an estuary, is going all through your engine, and that causes corrosion, mud buildup, all that kind of stuff. That's the reason that you flush your outboard at the end of each trip. What a car does is has the engine, and it has a radiator here and header tank, water's plumbed in and out of the radiator, and there's a fan on the front of the engine, air blowing as the car moves along, and coolant comes in through the engine back into the radiator. As we said before, the water gets hot as it goes through the engine, so it needs to be cooled, and this is done through a heat exchanger. In this case, the heat exchanger is a radiator, and it exchanges heat with the surrounding air, takes the heat out of the coolant, and keeps it at a temperature that can keep the engine cool. What Renko does is, has an engine, has another heat exchanger, same thing, very similar to a car. So you top this up, header tank, fresh water runs around, but instead of air blowing onto it, because it's in the engine bay of a boat, we draw water from a skin fitting, we put it through a heat exchanger. That heat exchanger is salt water, then it goes back overboard, sometimes out the exhaust. In my case, I've got dry exhaust, so it just goes out another skin fitting. And instead of cooling the coolant with air, we cool the coolant with salt water. This means that only the heat exchanger gets affected by, salt water, which means it will need cleaning, it needs anodes, it'll get blocked. But the coolant going through the engine is completely clean. It has anti-corrosive additives, all that kind of good stuff. Now, the final option, which is common on boats as well, but it's how we're going to do this outboard, I think, not that we've actually done it yet, is Daisy in the background wanting my attention. So we're going to have an outboard. We're going to take the water pump out, and we are going to have what's called keel cooling. So you have the pipes in the water, they're essentially the heat exchanger. Then we're going to need some sort of water pump that circulates it, goes into the outboard and out here. So we've got completely clean coolant with anti-corrosives, all that kind of glycol, all that kind of good stuff, going then under the water. So this is the transom of the boat. Goes under the water through these copper pipes. The heat gets dissipated into the surrounding water and pumped through the outboard. So we don't have any issue with salt water going through the outboard, mud getting through the outboard, sand if we run shallow, all that kind of stuff. That's what we're trying to design and build. Hopefully that explains what we're trying to achieve and why. This is an old 9.8 two-stroke, and we're going to be doing the conversion on a similarly sized four-stroke. I'm going to use this two-stroke to figure out how we might approach this problem, but I'm going to do the conversion ultimately on a four-stroke. They obviously work very differently in the sense that your exhaust comes through exhaust ports on a two-stroke and out through valves in the head on a four-stroke, but outboards are surprisingly designed quite similarly, so I think we'll learn a lot from this two-stroke anyway. This has a whole lot of broken head bolts. I've just realised I don't have a pair of vice grips here. I've got a pair on Renko, so I think I'm going to go and grab them before it gets dark. I don't need all the head bolts to be out, but I need enough just so we can hold a bit of a clear cover on here and show you where the water flows. So I'm going to go grab those and I will be back. Another green tree snake. Don't poke your tongue out at me. Anyway, we'll leave him alone. While I'm here grabbing the vice grips, this is the outboard we're ultimately going to do the conversion on. This was given to me by a viewer called Adrian, must be a guy called Adrian. So thank you, Adrian. I think this is going to be a really good candidate for this conversion. All right, I'm back from getting the vice grips. These two are still awake. Daylight savings, how good's that? All right, I was a little bit worried about getting these broken head bolts out, but fortunately there was Coopers on Renko, so I think we'll be fine. This long one sticking out seems like our prime candidate for getting at least one more out. I don't actually have any oxy torch or anything here at the moment. It's not moving. Yeah, looks like it is turning. Or is it just going to snap level? Yeah, there we go. That's all right. Fortunately, I have a cylinder block milling machine here, so we'll try that. So be sure to contact Dango Marine for all your engineering needs. My plan now is to drill some holes in this, put a bit of sealant on the block, and put the perspex on so that I can show you how the coolant flows through the block. All right, we don't have that many bolt holes, but we'll mark the ones we do have. One thing I've learned in my life is that if you mark all of them, drill them, none of them will line up. So let's kind of mark one, get a bolt in, mark the others. I did get some bolts while I was on Renko too, not just beer, which I think are right. Oh good, they are. So we're going to need about a 6mm drill bit, I think. I think that's what these are. I don't think we'll go drill press. I think we'll just... Does anybody else find these things never close? Man, they're a nightmare. That's because it's got clear plastic on the back still. Don't blame it on the good times, blame it on the Coopers. Now, if we get two in, we're in business. I actually don't have any Sikaflex here, which feels kind of wrong, but we'll make do. I think I got some RTV from exhaust or something, that'll do. The best sealant for the job is the one you've got. Okay, let's go, let's mark the rest of them now, I think. Nothing but net. Off the crossbar. Put some hair around it. Nailed it. All right. Here we have the head gasket we're going to use, which is all I could find. How about we just go the backdoor Benny on it. Before you do any jobs like this, it's important to don the appropriate PPE. It's also important to use old-fashioned terms like don. Alright, I'm going to doff my glove, and then we're going to clean out the water jackets with, just to make sure we can see mostly. Alright, I'm going to let this set for a little bit, then I'm going to bolt it down again, see if we can get a slightly better seal, particularly up here. No bolt up here, obviously. Alright, while that sets, let's have a think about what else we're going to do next. So, what I am going to do is I'm going to grab the base plate from this and show you where the cooling water used to come up into the outboard. This is the leg that came with this outboard. This is the pipe that comes up from the water pump, and it comes into this little cavity here. This lower cowling then goes down, gear selector here, technically muffler here. And then you can see this water transfers through this section and then comes up into the power head here. So we know the entry point of the water, no drama. I think now's probably a good time to show you the water pump that's normally on an outboard. Here we've got the classic flexible impeller that you basically always see in raw water pumps. Whether it's an outboard or a jab's gone an inboard, this is the type of pump you see. So we'll crack the cover off and I'll show you how that works. Here's the little impeller. These flexible, I believe they're neoprene vanes on it. What makes this work is either a cam in one section, like you see in a Jabsco pump, or the fact that in this case, you can see the shaft's not centered on the cup. So the vanes up here are bent backwards more than the ones here, and when they open, they create a larger volume and therefore suck water and air, so they're self-priming to some degree. When we do this conversion, we're actually going to take the impeller out because we don't need it. Why have this drain on power, which ultimately running a pump off the shaft does have? What interests me now is to start to figure out how much cooling we're going to need. Obviously, a car has radiator hoses that are, 1 or 2 inches in diameter. They're quite big. The pipe that goes up to the power head goes in here. So the inner diameter of this really is the outer diameter, tops 10 mil. So less than half an inch, 3/8 of inner hose diameter. What I'd like to do is find a way of rotating this pump at, say, 5,000 RPM, put it into a bucket, measure it for a minute, and see what the flow is. We've also got to consider that the water coming through the outboard at that speed is 20-degree water, whereas the water in our closed cooling system is going to be warmer. So lots of variables to try and figure out. It's also interesting with the heat exchanger, the slower we pump the water, the longer it's under the water in the copper pipes dissipating heat into the water, but the slower the water's going through the block. So we might have to get tricky about that. We'll figure something out. Okay, I am going to start putting a few more bolts back in this. After that, we're going to take the exhaust cover off. What do we need? 10 mil socket. And just in case I can't find one, here's the emergency 10 mil. 11. I might need the else. I was joking, but I think I might need it. I can't find my 10 mil. Thinking I probably should have done a 6.5 mil drill bit to give myself a little bit more play, but we might be all right. We'll see. If ever you do get bolts that are a little bit out of alignment, they're not really starting properly, just get a rattle gun onto them. Mechanics is all about sensitivity, not breaking anything, slow, measured. All right, let's have a look at the underside of the block and I'll show you where the water comes in. So we saw it comes from the pump, comes up the pipe, went into the midsection, then it went through that lower cowling, a little bit of cavity. Once the water comes through that lower cowling, comes up into here, but obviously it can also come across here, go down there. No, it doesn't go anywhere. So this is solid, but it comes along here. Then it can go in here, And down there, this is obviously sealed by the base gasket. So we need to figure out where all these places go. I'm presuming water flows around here, you know, to cool the lower part of the block. This is ultimately a water jacket, not protected by the thermostat, so water will flow here all the time. Okay, I think next we'll take the exhaust cover off, and in lieu of the smoke machine, I think I did it with the old gearbox video, we'll try just spraying a few aerosol sprays and see if we can see where things are coming out. This bolt you can see here is the top of an anode because water comes in under the exhaust cover. Alright, let's get a little pry bar. I did say a little one, didn't I? Alright, so once it's on, you can come in, around. Actually, let me take this gasket off. That'll show you much more clearly. Definitely gets a little bit tricky here. So, comes up. Comes straight through this midsection into the top plate. It can then flow around into this center section from 3 points, which fills this cavity. What you can hopefully see here is that this hole here comes through to the water jackets. Hopefully you can see there, that's the tip of the pick coming through there. So what that means is that once the water comes up to this top plate, goes around the top plate, goes down through this jacket around the exhaust, and then rather than going into the exhaust, actually just comes out the bottom here into the leg. Down here, I'm not sure you'll be able to see, but down here there's 2 holes that go into the water jacket as well. So this is why water gets to flow here and back out in a small amount before the thermostat opens. If I hold this light here, you can hopefully see in the very center there, there's another hole in that water jacket around the exhaust that goes into the water jackets around the bores. I've put some more sealant on this. What this ultimately simulates is how the engine works with a closed thermostat. I'll bolt this up and we'll let it set overnight. I'm gonna have to finish this tomorrow because I think we're gonna have to either put a bit of water in or maybe some compressed air, just so we can feel where the air's coming out. Anyway, in the morning, we shall see. Good morning. Sealant's dried now, so we're going to fill this block up with some water and just show you where the water travels to. I've also put the exhaust cover back on. We tore the gasket there, so a bit of sealant on there as well. I actually already poured water in here, if you notice it's wet, but of course I had the wrong camera selected. Clearly not a morning person. All right, let's grab this water. Just in a bottle, we don't need too much. And we're just simply pouring it in to the exact place that the water pump delivers it to. Down the bottom here, you'll see the cavity. A little bit hard to see. I need glowing water. I'm going to fill this right up. You can see a little bit of water here in this cylinder, and this is exactly what happens when your head gasket blows. Water comes from these water jackets, crosses in, and you start getting water inside the bore. What this is showing me is that the main inlet, this hole, and this hole are all connected as a part of the water galleries, but water only comes out of here when the thermostat opens. Hello, it's Stu from the future to show you a couple of things that I didn't film properly the first time. Notice while I was editing. This section, as you've seen here, fills with water, and this is where it's allowed to come out to be the telltale. There is also another hole that comes down here, and that is this one here. It's a little bit back from the intake and a little bit inboard, so it seems to just send water down the inside of the leg. If we put this lower cowling on, you can see here, this hole here lines up with the telltale, and this one that's still dark goes down inside. This one here goes out here. The thermostat goes in the top of the block here. Water, as we saw, was filling all around here. So the back of the thermostat that senses the water temperature sits in this water. When it gets hot enough, it opens, and then water can flow into this cavity, down the back of the cylinder head along this channel, and out through that port that we just showed was isolated from the rest of the circuit. What that means is we have a very small amount of water circulating around the water jackets due to the two outlets, the telltale and the smaller outlet going into the leg. Then when it gets warm enough, the thermostat opens and a large amount of water can flow going straight out that exhaust port that's really just at the very back of the outboard. If this isn't making a lot of sense, it's pretty much my fault, not yours, don't worry. Because it's taken a while to sort of get my head around this specific outboard. The Honda, which is now here, once again, thanks to the magic of jumping to the future, is going to be different. But I feel I've now got my head around this outboard, and also it's dawned on me, slowly as it's been, what's the important thing to know. And really, I think it comes down to treating this cooling system as a bit of a black box. You don't really need to know all the details. You need to know the inlets and the outlets, and that's pretty much it. So what I'll do now is I'll quickly show you a diagram of this outboard without all the specifics, just the information I think I need in order to do this conversion. I know a few of you also work in IT like I do, and really what you're thinking of is this a bit of a black box. It's like a class with an interface. All that really means is we don't really need to know the details of where this water flows inside here. We need to know it's got one input, which is lots of water in, two small throttled outputs that flow all the time, and one large output that flows when the thermostat's open. And really that's all the information we need. Based on that rather obvious realization, yes, I'm a little bit slow when it comes to these things sometimes, aren't we all? Well, I like to think so. Is that approach is going to massively change the way I now investigate the Honda. So hopefully when we do this, it won't be a long laboured video. We'll be able to get to the point of figuring out all the inputs, all the outputs, know where we're at. So what I'm going to do now is quickly show you my off the top of my head plan. This is not the final plan at all. I'm going to have a chat to Adrian about it tomorrow because we're working together again tomorrow. Because he's always got great ideas for this kind of thing. So I'll show you what I'm thinking, and we will continue working on a better design before we start modifying the Honda. Think of this black box here as the power head of the outboard. My plan is to have a header tank up here, radiator cap, expansion tank, maybe recovery cap, maybe let it find its own level, we'll see. Then somewhere on this line that comes to that single high volume inlet on the power head, we'll have an electric pump somewhere here. Do we get fancy and link it to RPM? We'll see. You know, that'd be just an interesting challenge. You know, anyway, we can take a signal, like a tacho signal, and make that happen. Then we've got our two continuous little outlets, and they're just going to go back into the header tank. Then, when the thermostat opens, we're going to send this water through our Keel-cooling, and then also back into the header tank. This is a bit different to a car in that normally you would have a thermostat that's a bit of a valve. It says, while I'm closed, circulate in the block. When I'm open, don't do that. Push all the water through. If we have this setup, when the thermostat's open, some water is still going to come out through these pipes. Is that a problem? I don't know. I don't think we'll really know until we do some testing, but this is the basic design I think I'm going to go with. Another thing we could add, and this is something that kind of interested me, I didn't think of it living in Australia, but a lot of people have said they've thought about doing this project because here, between the outlet from the engine and going to the keel cooling, you could run up to a cabin and have a heater like in a car. It's interesting to see that a couple of viewers who live in cold climates have seen the main reason for doing this is to have a heater in your boat. So that's pretty cool too. I think we should do that just to show it's possible. Okay, I'm going to edit this quickly and get it up online because it's been a while and back to work in the morning. But I think we're getting close to a design. I think there are going to be extra complexities with the Honda, and that's fine. I think it's good to see a couple of outboards and see how they differ. Hopefully this video has given you an idea of how the cooling in an outboard normally works, and hopefully next video we'll be getting into some actual fabrication and making this conversion. Now, there's lots of ways we can physically do this. There's going to be challenges there as well. a way I'd really like to do it is to have a thick aluminium adapter plate that goes between the lower cowling, the leg, and the power head. It means we can tap off, you know, with various tails, threaded tails. We can block off things we need to block off. I think it could be a really elegant solution, but we're also then going to need to fabricate a rim so the cowling's an inch taller as well. Otherwise, the pull start won't match, it may hit the top, all that kind of stuff. So a few challenges, but I really do like the idea of it being non-destructive, that you put this base plate in, bolt it all back together with some longer bolts, and you know, you're on your way to installing a kit. So lots to think about, looking forward to it, and I'll hopefully have you guys along for the journey. All right, take care, I'll catch you then. See ya. Somebody hates the fact that she's now getting locked in overnight and has to be let out in the morning. Who would that be? Would that be this noisy chicken? I think it might be. All right, come on. Ugh. Out you come. Get on with your day. Go on. After you. Go and explore the garden. I've got to go to work. Stay out of trouble. Go on. Shoot. Nothing for you inside. That's where you live, outside. Isn't it?